So the next topic we are going to be looking at is called exponential functions. This is very similar to what we just talked about last week when we talked about a geometric sequence. Referring back to how we related the arithmetic sequence to what we talked about with linear. The geometric sequence is going to take a lot of similarities with these exponential functions that we're going to be looking at this week. So we're going to spend a couple days this week on these exponential stuff. You're looking at a test on Friday, so the test will cover all of this exponential stuff plus the sequence stuff that we did, last week. Okay, so exponential functions here. This is a generic equation that you will see. This is a formula you will see and how to write these guys. So very similar to a lot of the concepts that we talked about with linear functions, but kind of the variables that we see here take on a little bit of different meaning here. All right, so the first variable that we see, in order to write this equation, you need two parts. We've got to figure out what A is, and we've got to figure out what B is. These x and y variables, these are just coordinate points, the values x and y. Just like we saw with the linear functions, we've got an input x for an output of y. So all these are just the relationship between the function. This is just a coordinate point. The main part that we need to go find is we need to find A and we need to find B. Okay, so this A value, okay, well, it may be referring to our geometric sequences. This would be the first term. Okay, you got to know where it starts. Okay, in order to write the equation of something, you got to know where it starts and how is it moving. Well, this A value is what's going to represent of how it starts. So this is your initial value. Right, another word to kind of refer to starting value would be initial. So it's more commonly referred to as initial value. But we're going to get into some examples for with using tables. So more important to you guys, this is when x is 0. Okay, so in order to find that A value, we need to know when the value of x is 0. Right, we've gone over examples before. When you're born, you're born in year 0. Right, you're not born in year 1. So we start when our value of x is 0. Okay, and the other part, the more important part, I feel, and what really makes this exponential is the B value. Okay, the B value is referred to as a multiplier. Okay, so last week we referred to this in a geometric sequence as the common ratio, right? We were finding that fraction that made in order to get from one number to the next. Now that we're talking about an exponential function, we're looking for a multiplier. Okay, so kind of the difference between, a linear function and an exponential function. Linear, remember how we talked about it was that constant rate of change. We talked about what number was being added or subtracted to get from one number to the next. Now that we're dealing with exponential, it's a multiplier. What number are you multiplying to go from one number into the next? Okay, so I've got 6 examples here for us. We're going to look at some what happens with the numbers are increasing, and we're going to look at some numbers when they may be decreasing. Okay, so let's start out with the increasing stuff first. All right, so when we talk about exponential functions, increasing is referred to as a growth. Okay. This is kind of an odd time, with this virus spreading. Maybe you've heard people talk about how it's growing exponentially. Well, this is exactly what we are going to be computing. Maybe earlier in the semester you remember doing the Stanley and Velma virus outbreak thing. Okay, now we're going to be able to write equations for that event here. Okay, so again, we need two things. We need an A value, right? We need an A value, and we need a B. We've got to find these two values to put them together in order to write the equation of this curve. We're going to get into some graph stuff in the next couple of days. I'm just more focused on our tables here. All right, so the first one should be pretty easy to see there, right? Remember we talked about how the A value is our initial and when x is 0. So if we look at our table, right, our x value is 0 and our y value is 2. So it should be simple enough that the A value is 2 here. Okay, so now we need that b value. How are the numbers moving? How are we jumping from one number to the next? And we can tell that this is an exponential growth, or this is increasing. Notice when the x values are increasing, y values are also increasing, right? So very similar how we did with geometric. Um, it might not always be easy to eyeball how we get from one number to the next. I think a lot of us could probably see that, in order to get from 2 to 6, all we need to do is multiply by 3. But we're going to get into some maybe more challenging examples where you might not always be able to see that value. So in order to find this b value, right, to go from 2 to 6, okay, well, if we need to find the multiplier, the opposite of multiplier is division. So I'm going to divide the two numbers that I see there. Okay, remember referring to, let's zoom in on that a little bit more. That second number you see divided by the first number that you see. Okay, so I see 6 second, see this 2 first, so I'm going to take 6 divided by 2, and like you said, we've been around numbers long enough that we knew 2 times 3 takes us to 6. And just kind of prove a little bit more, remember it needs to be the same kind of throughout. Let's see if it works the same way for 18 and 6. So to find the b value there, I'm going to take the 18, I'm going to divide it by the 6. Well, again, 18 divided by 6 is 3. So wherever you're at in the table, if it is an exponential function, it should have that same multiplier everywhere you see it, okay? So now that's the second piece of the puzzle that I need. My b value is 3, so now I need to put the pieces together. So we have y equals, right? Oops, sorry. A times b raised to the x. Okay, so y equals this a value that I saw times, and if you want to put it in parentheses, I think it probably is going to help you out a little bit better to see it, times the b value being 3. And a dead giveaway, I should have said this earlier, but a dead giveaway that it's an exponential function. Well, a rudimentary word of exponential is exponent, right? Notice where the x is at in our equation. The x is hanging out in the exponent, right? Kind of give away that we are dealing with an exponential function. Okay, so that is the equation that is going to be directly related to that table for that example. Okay, so again, I'm going to show you two more examples with exponential growth, and then I'll post another video of exponential decay here. Okay, so the next example, tables can be written vertically or horizontally, so I'm going to show you kind of both ways just so you don't get distracted by it. So here we go. Remember, we need our two pieces. We need A. We need B. Okay, so I think the easiest thing, if you find it, if it's given to you, find that A value. So remember, it's not always the first number listed in the table. We need to find when x is 0. So we have an x value of 0 here. And it looks like when x is 0, my y value is 6. Okay, so which means my A value is going to be 6. This function is going to start at 0, 6. So again, just don't get crossed up and where the number's at in the table. You are trying to find when x is 0. Also, notice again when my x values are increasing, right? We went from -1, 0 to 1. Look at my y values. They went from 3 to 6 to 12. Okay, so they are getting bigger. So this is referred to as a growth. All right. So the second piece we need to find that b value. We need to find that multiplier. So again, if you can eyeball it, awesome, cool, great for you. But, sometimes you may not be able to see it. So mathematically, we're finding that multiplier. So I'm going to do the opposite, and I'm going to divide by the two numbers that I can see. So if I'm going from 3 to 6, I'm going to divide 6 by 3, which is 2. Okay, and just to double check to make sure this truly is an exponential function from what is given to us, I'm going to go ahead and take the other two numbers that I see there, 6 and 12. So what number do I multiply 6 by to get 12? So I'm going to divide 12 divided by 6. And again, 12 divided by 6 is 2 as well. Sorry. Okay, so however way you shape it, whatever numbers we're using here, it looks like my b value is is a 2. Okay, so again, those are the two numbers that you need. Where does it start and how is it moving? So let's put our pieces together. Y equals, my A value was a 6. Again, I'm going to use parentheses. You can use the multiplication dot. It really doesn't matter. And then my multiplier we just found to be 2. Okay, it is always nice to kind of go back and double check to see if your equation is right. You know, you've got values of x and y here. Okay, so when x is 1, y better come out to be a 12. So if I put a 1 in for this x, order of operations tells me to do my exponent first. 2 to the first power is 2. 6 times 2 is, well, 12. So, you know, this is just a relationship. You know, if you're struggling or, you know, you don't know if you're right or not, substitute the coordinate points back in and see if they work there. All right, so one last example. Again, it doesn't matter if the table is written vertically or horizontally. I showed you both ways there. Okay, so this one, okay, maybe you can observe that the x0 was not given to you. You know, we see some numbers that, you know, it gave us 1, 2, and 3, but it's not always the first number given to you. We have to know what happens when x is 0. So if it's not given to us, we need to go find it. And the way we got to find it is we need to find out how we're getting from one number to the next anyway. So we got to find our multiplier. Again, how are we getting from 10 to 15? So this one might be a little more difficult to see. Remember, you're not adding and subtracting. So don't say, oh, well, I'm just adding 5, right? That's linear. What are we multiplying by to get 10 to 15? So again, if you can't see it, which is perfectly fine, use the algebraic approach. So 15 divided by 10, right? I want to know what multiply 10 by to get 15, so I'm going to divide 15 by 10. Hopefully you have a calculator handy. These functions will get pretty difficult if you don't have a calculator. We talked about how Calculate 84 is a great app for, I know, on the Apple market, but any kind of internet calculator will definitely do for this. So I'm going to put my calculator 15 over 10. Okay, and this turns out to be a 1.5. So I'm going to give you your first warning for this. Be careful. I'm going to show you my calculator. Be careful with decimals. I know I've stressed this a lot throughout class. This decimal is okay. It terminates, right? 0.5, you know, there's no other numbers past this. So this decimal will be okay to use. But you will run into decimals that are never ending, okay? So remember, math, enter. If you're using that Calculate 84 or, you know, being able to find that fraction, the fraction here is also 3 over 2. So I'm going to write that down, write that down as well. Okay, because we may run into examples of something like this. You cannot write that number down. I know this number stops, but that's only because there's only so much room in the calculator. That 3 will go on forever, okay? So you're going to have to get used to the fraction, okay? If you understand the difference between a terminating decimal and a non-terminating decimal, then you know what? Like this example here with the 0.5, it's okay to use that 0.5. But we run into something that has a repeating decimal like that, you cannot write the decimal. You've got to get used to the fraction. Okay, so just kind of to prove again, to see if that other number works, let's look at that 22.5 and divide it by the 15. And notice how it is the same exact multiplier to go from there. Okay, but we still don't have x at 0. Well, if this is a multiplier, right, we are multiplying to get from 10 to 15, right, what operation should be coming back? Well, you should be dividing coming back. So if I'm at 10, right, if I'm at the number 10 and I need to go backwards to term 0, I'm going to divide by that 1.5. Right, so I'm going to divide by the 1.5, and notice how I got smaller, right? That's because we're working back up against the table, okay? So this is actually an ugly example. That's 6.6666. That's weird, okay? I'm going to turn it into a fraction, which is 20 over 3. should have made a nicer example for you there, but it's all the same thing. Being able to use that multiplier to work up and down the table there. So it looks like my a value is a 20/3, and just kind of to show you that it does work. It kind of makes our table work there. So if I do 20/3 and I multiply that multiplier that we've been finding, that 1.5, it should take us to the next number in the table being 10. And you can see that it does there. Okay, so again, the whole goal of this is being able to write the equation y equals that a value that I just found. And again, I'm sorry, this turned out to be an ugly number. Okay, my multiplier is the 1.5. Again, we can write, we can write the 1.5 since it is a terminating decimal, and we need our exponential function there, so we have an exponent for x. Okay, so those are 3 examples of exponential growth, right? Notice how the numbers were getting bigger. The next video I'm going to post is talking about exponential decay.